So today we're going to be taking a little bit of a review of sine and cosine and their curves because we've been doing some other things the past week, just some old review types of assignments. Anyways, so we're just going to take a look through some questions on things we're going to be asked to do in this assignment, and then we're going to use the last question as a model for all of those things. So firstly, the first question asks us to find a maximum value, so we'll be able to do that. Find the range, we'll find the range. We'll be asked to find the amplitude. We'll be asked to find an equation with a specific period or frequency. And we'll be asked to determine which graph looks accurate. And I think that's mostly everything that's being asked to be done. Increasing and decreasing values would be an important part of this assignment as well. And that's about it. So we're going to use the last example to do all of these things. So firstly, we're going to distinguish between the sine and cosine curve. So if we were to look at a curve, there are two types of curves. There are the sine curve, which starts at its midline, rises up to the maximum, falls back to the midline, decreases to the minimum, and then increases back to the midline. This is the sine curve. Now, if you were to make the a value negative, then the graph would begin at the midline and go down to the minimum, go up to the midline, back to the maximum, and back to the midline. So it would reflect over the x-axis. Now the cosine curve starts, it has a midline, but it doesn't start at the midline. It starts at its maximum, goes to the midline, goes to the minimum, so it starts at the max, goes to the mid, and reaches the minimum, returns to the mid, and then returns to the maximum. So this is the cosine curve. So that's cosine. Now the reflected graph is negative cosine. So if there's a negative value for a, the graph will begin at the minimum, then go to the midline, then to the maximum, back to the midline, and down to the minimum. So the graph will look more like this. So that's determined by the amplitudes. All right, so looking at the graph we have here, it starts at the middle, and it goes down, and then it goes down. So that means it's a sine curve because it starts in the middle, and because it starts going down, it is a negative value. All right, so I'm going to erase this for now. All right, so looking at that graph, we know we're using a sine curve, so it's y equals a sine of b x plus d, and in this case the graph starts going down, so we know we have a negative a value. We don't know what the a value is yet, but it's sine. We don't know what the frequency is yet either. Remember, this is the frequency. But we can see in this case that the midline is 0, so it's plus 0. And you'll notice all of the choices have no midline on them, so all of them could be correct based on that, but some of them are not negative. Next, if we look at the graph closely, the amplitude is the distance from the midline to the top. So the distance from 0 to 2 is a distance of 2. So that's our amplitude. So it's negative 2 sine of something x. There may or may not be a b value. Don't forget the period is equal to 2 pi divided by the frequency, and vice versa. The frequency is equal to 2 pi divided by the period. Now in this case, we can see that this graph has a period of 2 pi. And the reason for that is because this graph completes an entire cycle. That's back from the middle all the way back to the middle at 2 pi. So that's the period. So we can find the frequency, which is what we need for our formula. So the frequency is going to be equal to 2 pi divided by 2 pi. So the frequency is equal to 1. So this equation is y is equal to negative 2x, y is equal to negative 2 sine of x. Other things that the other questions have asked about that we should address is looking at this graph carefully. The maximum value is 2. We can see that that's the midline, 0, plus 2, regardless that the a value is negative. The minimum is negative 2, which occurs when we take the midline and go down by 2, regardless of whether the a value is positive or negative. The distance between the maximum and minimum is 2 amplitudes, so it's 2 2's, or 4. All right? And I think that pretty much covers everything we needed to discuss here. Actually, also we were asked for the range in some questions. So the range is the minimum y value to the maximum y value. So we can see that it goes down to negative 2, and it goes up to 2. And otherwise, every question on this assignment is some variation of those things. Oh yes, increasing and decreasing. So if we look at a sine curve, again, or use a cosine curve in this case. So for a different question, let's say I gave you y equals cosine of x. So the cosine curve starts at its maximum, goes through the midline, down to the minimum, back through the midline, and back up to the maximum. So this is 1, negative 1, 0. Now, if we were asked when it was increasing, this graph is increasing from 0 up, from this point, the minimum, negative 1. Let me change colors maybe. From negative 1 up to 1. So this is where it's increasing. And it's decreasing from the beginning of the graph at positive 1 until it reaches negative 1. So this is where it's decreasing. If I asked you what sections of the graph that's doing this from, if we remember that the graph ends normally at 2 pi, that means the middle section is pi, or halfway. The beginning is 0. Between pi and 0 is pi over 2, or a half of a pi. And then because that's a quarter, this would be 2 halves pi, and this would be 3 halves pi. So it's 0, half a pi, pi, 3 halves of pi, and 2 pi are the 5 sections of the graph. So 0, half pi, pi, 3 halves pi, and 2 pi. So this graph is actually decreasing from 0 to pi, and it's increasing from pi to 2 pi. And that's pretty much all you should need to answer these questions. They're all just variations of these things. If you have any questions, just let me know, and I will try to answer you to the best of my ability.